Hello. So I'm doing another example on variations, and I wanted to dig just a little deeper. What if we had been given the volume and the flow rate, but we didn't know the time? So let's take that volume, the total volume, and we're going to divide it by this 100 milliliters times hour. No, not 1 hour. So when we do that, we end up with 10 hours. So that's how you can calculate your time. So if you're ever in question, that's how you calculate the time. In this case here, it was all given to you. So let's solve. The first question says original flow rate and drops per minute. We have this order here of a flow rate of 100 milliliters per hour. And we have this drop factor of 60 drops per milliliter. So let's solve for it. So we got 100 milliliters over an hour times at 60 drops per milliliter. Now, if you want to, we can replace the H with 60 minutes because we need it to be in minutes, right? Some of you will probably want to keep the H and do the extra conversion, and that's okay. If that's what helps you, then that's what you need to do. Okay, so I can reduce my milliliters. Now I have, oh, and I left the zero off that 60 there. Now let's reduce. Well, I noticed 60 goes in itself once, going to this once. Oh, this worked out nice and pretty. So we have 100 drops per minute. Now remember, 60 drops per milliliter is a tiny drop. So you can have a whole bunch of them, okay? Now it says that after 4 hours, something went wrong during the process of the infusion. After 4 hours, you have a remaining of 600 milliliters left. We want to know what's our remaining time. So again, our total time was 10 hours. So we're going to subtract the 4 hours, which gives me 6 hours. So that's my remaining time. Now let's calculate our, recalculate our flow rate because, you know, we have a different volume left and a different time. So our remaining volume is 600 milliliters. Our remaining time was 6 hours. So that worked out to 100 milliliters per hour. So that is our recalculated, our adjusted milliliters per hour. Now let's do our flow rate in drops per minute. So we got the flow rate in milliliters per hour. Let's do the drops per minute. So I'm going to take my 100 milliliters that we just solved here. I'm going to put in the place of the H 60 minutes. I'm going to multiply that by our drop factor because remember that's still the same. You know, that's what's plugged up to our patient. And this works out great. The milliliters reduced, 60 reduced. Now I'm left with 100 drops per minute. All right, so now let's solve for the variation and then let's talk about its action. So our original is going to be 100 drops per minute. Our adjusted is 100 drops per minute. Our formula is our adjusted minus the original divided by the original, all times 100%. Okay, so our adjusted is 100 drops per minute minus our original 100 drops per minute, all divided by our original, which gives me, when I multiply this out, hang on. So 100 minus 100 gives me 0 on top, divided by 100, then multiply by 100. This is just 0. My answer is 0%. So this is perfect. Well, my action can be, we're not going to change anything. It's just the way we need it to be. So 0% is my action, or sorry, my variation. I'm getting tongue-tied. So my action here. So if we have this 25% protocol, we have 0% right here. As long as it falls between the negative 25% and the positive 25%, we're going to call it good. However, 0 is perfect. It's exactly what we want. That means that whenever we readjusted the flow rate and set it up, nothing changed other than we just lost a little bit of time. So if it falls on the outside of this positive 25%, then we're going to say it's too slow. If it falls on the outside of this negative 25%, we're going to say it's too fast. So in this case here, it's just right. It is good. Thank you.